geological or evolutionary perspective on the impacts of climate change on ecosystems, it's really not much to worry about. We've seen shifts and extinctions with warming and cooling over thousands and millions of years, and these have been driven both directly by climate and linked changes in the chemical and geological conditions within which these ecosystems occur. It's a natural process. Species go extinct. When you have a big climate shock, many more go extinct, but then new species evolve to fill the ecological niches that have been left by those going extinct. Biomes shift north and south as we go through ice ages, into and out of ice ages. And overall, in the end, we've had a functioning global ecosystem that's been changing and evolving over the last 4 billion years. It's still around. So that kind of long-term perspective would suggest that climate change is just a blip in the process. The big difference today is, of course, humans. We've now become integral parts of these social ecological systems, and we care about the services that they provide and what climate change might do to those services, both from a philosophical and spiritual point of view, but also from a much more instrumental point of view in terms of how climate change will affect the services that these ecosystems give to us. There are two big factors one needs to bear in mind when one thinks of humans within these changing ecosystems. And the first is the way that society is structured. We generally are a sedentary species. We've got fixed structures that are fixed in space. So we have homes, we have property, we have cities, we have water resource systems that are fixed. We have national boundaries, we have farms, and all of these things are things that hold us in a particular geographic location. And with climate change, the ecosystems upon which we depend are shifting and moving. So what climate change really means is that we will have to be prepared to adapt our own way that we interact with these ecosystems and the benefits we get from them to their shifting structure and function as climate change evolves. So for instance, where I live in Cape Town, I really enjoy walking on the mountain in the beautiful fynbos biome. It may be that in 50 years' time, I'll be walking in a grassland rather than in a shrubland, for instance, and I'll have to get some other kind of aesthetic pleasure out of doing that. The other big difference that that humans make is in the way that they've modified the landscape. So you just need to look out of your window and look at how there's a human footprint on the structure of the landscapes and the ecosystems within which we live. Roads, farms, it's various other patches that make for a fragmented natural landscape. So roads, cities, farms fragment the natural landscape and make it much more difficult for the individual species within these ecosystems to then undergo this adaptation of migrating as the climate changes. And so our modification of the landscape is really perhaps acting as a further barrier to the abilities of natural ecosystem responses to climate change. Given how we've sort of talked about these social ecological systems, so humans embedded in ecosystems, it's obvious that there are many other factors that affect ecosystems over and above climate change. They've been responsible for many changes in ecosystems in the past, are operating now, and will continue to operate in the future. And they'll interact with the direct effects of climate change to affect the overall health of ecosystems. Firstly, these other processes will affect the sensitivity of ecosystems to these direct climate change impacts. And secondly, climate change itself can work to affect the sensitivity of ecosystems to these other factors. By far the biggest impact on ecosystems, way above that of climate change to date, has been land use change and land cover change. Humans, over sort of the period of the last few thousand years, and especially in the last 100 years, have converted huge proportions of the land surface of the earth for agriculture and for forestry, especially agriculture, and also for human settlement, converting into cities and towns. About 40% of global land area has been converted from natural ecosystems into cropland, commercial forestry, and pasture. And then a further 20% was converted and has now been abandoned and is sort of reconverting or transitioning back into what we call secondary forest or grassland. That's the recovery of those ecosystems. So in total, 60% of the global land surface has been converted at some stage or another by human beings out of a natural system into a managed system. These conversions have obviously had very important short-term gains. It's provided the food that people need to survive. It's allowed for intensified agriculture to feed a population of 6 to 7 billion people, and it's provided cities and urban areas for people to live in, and all the efficiencies that in terms of providing food, water, and other services that those conglomerations provide. But it's been at the expense of other services. So when you convert land for agriculture, you are losing a whole range of other services that the natural ecosystem would have been provided. So this has really been the most dominant factor in the health of ecosystems, this land cover change. But there are other drivers as well that affect that have caused ecosystem change. These are varied, but one of the biggest ones is pollutants, various kinds of pollutants, fertilizers that then feed through into the ecosystem. So, for instance, nitrogen used for farming then percolates through into the aquatic systems and leads to what we call eutrophication, so too much nutrient in aquatic systems, and the growth of algae and the loss of other plant species and a reduction in biodiversity. Pesticides and herbicides that are used in farms have impacts on the diversity of the surrounding areas. And for instance, we believe that the collapse in bee populations across much of Europe is due to these pesticides and herbicides affecting their resilience to fungal infections. Another huge human impact has been invasive species. So through an increasingly globalized world, we've had the transfer of species from one part of the world to another, and in many cases they outcompete the native species and then take over those areas. So a really interesting example is the zebra mussel in the USA, which came outside of America and is now dominating the freshwater, what we call mollusks, shelled species within North American freshwater systems. River regulation has also been really, really critical in affecting the function of aquatic ecosystems. By regulation, we mean the building of dams, the transfer of water from one watershed to another, and the possibility of accelerating invasive species invasions through that. And then through these building of dams, we fragment the river systems. So in North America, dams prevented the migration of salmon up into the headwaters, which is where they spawn. So you're breaking a natural cycle, a reproductive cycle in key species within North American river systems. Dams and our use of water also leads to what we call flow regulation. So we change the natural flow regimes in river systems by changing the timing that flood happens, reducing floods, which are critical for triggering some of the breeding cycles of aquatic species, for instance. Our other big impact has been just through overharvesting. So through overfishing, for instance, deforestation for tropical forest wood products, overfishing in ocean areas then leads to severely degraded ecosystems because of the loss of species within these systems. And then a final really important impact of human activity in terrestrial ecosystems is through erosion and soil degradation. So through overuse and over-farming and bad land management, we are losing good quality soils that have evolved in ecosystems over hundreds and thousands of years. And the rate of erosion and removal far exceeds the rate at which natural ecosystems can replenish those soils. So we essentially are using or depleting soils at an unsustainable rate, which is one of the reasons why there's so much abandoned farmland in terrestrial areas.